Okay, so we know that density is what determines whether something is going to rise up or sink down. When it comes to something like oil and water, oil is less dense than water is. So oil is naturally going to want to rise. But what happens if we were even to start out by putting the oil intentionally at the bottom? If I put it all the way at the bottom of the container here and let it go, you can see it naturally automatically rises because oil is less dense than water is. Well, what does that have to do with plate tectonics? It's the same exact thing. Something that is less dense is going to want to rise to the top, and something that is more dense is going to want to sink to the bottom. In the case of Earth and its mantle versus its crust, temperatures will change, and with the change in temperature, that winds up changing densities. Have you ever heard the expression to warm up or to cool down? It's because you're changing the density of either the liquid or of the gas. So in the case of the mantle, that rock is so soft because of temperatures coming from the core. So in my bowl here, I have very, very hot water. I've heated it up in the microwave. And I've got very cold water. In fact, there's still ice cubes in it. Let's remove the ice cubes. So I've got cold water and hot water. If I place my cold water into my bath of hot water, I am going to start what we read about in our book, known as convection currents. As things heat up, they're going to go from the bottom up the sides where they're going to cool off at the top, go to the center where it's nice and cold inside this, and drop down again to the bottom. As they warm up, they wind up spreading out, heating up on the outside and rising up. So how can we possibly see this since water looks like water? I'm going to use some food dye. And food dye is water-based, but it's at least going to show you what's happening in terms of the movement of water. So we're going to add this orangey yellow, and I'm going to put it right towards the middle. And are you ready? I'm going to let it go. Can you see that instantly the dye went right to the bottom, spread out to the sides where it's heating up, and can you see it literally crawling up the sides of the glass? That's all right now convection currents. Convection currents, you can see it crawling up the lid, the edges there. We'll try it again. If I were to drop more food dye, it immediately goes directly down to the bottom. It's heating up, it spreads out, and it's filtering up the edges or up the sides. That's why as something heats up, the density becomes less and it wants to rise. As something cools down, the density becomes greater and it will sink, just like Earth's rock.